আচ্ছা, আমরা মাল্টিভ্যারিয়েট ক্যালকুলাস আগে যে লেকচারগুলো আছে ওগুলোতে দেখবে লিমিট কন্টিনিউটি নিয়ে মোটামুটি ডিসকাস করা হয়েছে। আজকে আমরা ডিফারেন্সিবিলিটি যে ব্যাপারটা সেটা নিয়ে একটু ডিসকাস করব। একটু অন্যরকম ভাবে ডিফারেন্সিবিলিটি আমরা শো করব একটা ফাংশনের ডিফারেন্সিবিলিটি। ডিফারেন্সিবিলিটি একটা ফাংশনের ডিফারেন্সিবিলিটি নিয়ে স্টাডি করতে চাই আমরা একটা পার্টিকুলার পয়েন্টে। আমি একেবারে ডেফিনেশনটাই দিই, ঠিক আছে, যে একটা ফাংশনকে কখন ডিফারেন্সিবল বলা হবে। তাহলে তার জন্য আমি কি করছি দেখো, এফ একটা ফাংশন নিচে লেট এফ যার ডোমেন ডি সাবসেট R2 সেখান থেকে আর এ রিয়েল ভ্যালু ফাংশন বি এ ফাংশন অ্যান্ড এ বি একখানা পয়েন্ট নিচ্ছি ডোমেন থেকে ডেফিনেটলি এ বি বিলংস টু ডি, ঠিক আছে। তো এবার আমি কি করছি দেখো, let us choose hk order pair hk belongs to R2 such that a plus h b plus k এই যে পয়েন্টটা আর কি, এই পয়েন্টটাও যেন আবার দিতে বিলং করে। এরকম ভাবে আমি একটা hk অর্ডার পেয়ার সিলেক্ট করলাম। then f is said to be differentiable at AB if limit hk tends to 0 0 delta f minus df by rho is equals to 0 হয়। যেখানে রোটা কি জিনিস, রো হচ্ছে রো এর ফর্মুলা রুট ওভার অফ এইচ স্কোয়ার প্লাস কে স্কোয়ার, তারপর ডেল্টা এফ দিস ইজ এফ অফ এ প্লাস এইচ বি প্লাস কে minus f of ab and df this is h partial derivative আগে দিন ডিসকাস করেছি fx ab plus k fy ab। ওকে, মানে পার্সিয়াল ডেরিভেটিভ গুলো এক্সিস্ট করতে হবে তাহলে বলো ডিফারেন্সিবল হতে গেলে। ডিফারেন্সিবল হতে গেলে এই পার্সিয়াল ডেরিভেটিভ গুলো কিন্তু আগে এক্সিস্ট করতে হবে। এগুলো যদি না এক্সিস্ট করে তাহলে আমি ডিফারেন্সিবিলিটিতে এগোবোই না, বুঝা গেছে। এগুলোকে এক্সিস্ট করতেই হবে, এক্সিস্ট আমি ধরে নিচ্ছি এরা এক্সিস্ট করছে আর কি। বেশ, এবার আমি একেবারে প্রবলেমসে চলে যাই। খুব ভালো একটা প্রবলেম নিয়ে একটু আলোচনা করার চেষ্টা করি আমি। হ্যাঁ, একটা কোশ্চেন নিই যে so that fxy ডেফিনেশন ডিফাইন করছি x কিউব minus y কিউব divided by x square plus y square xy not is equals to 0 0 and 0 consider করে নিচ্ছি when xy is equals to 0 0, ঠিক আছে। তো এই ফাংশনটা 0 পয়েন্টে কন্টিনিউয়াস দেখাচ্ছি so that this is continuous at 0 0 but not differentiable. Differentiable at 0 0. কন্টিনিউটি ব্যাপারটা বোধহয় খুব একটা প্রবলেম হওয়ার কথা নয়। কন্টিনিউটি ব্যাপারটা আমি দেখাতেই পারি এমনি ইজিলি। কন্টিনিউয়াস হবে মানে তো অলরেডি আগের কনসেপ্টেই হয়ে যাবে। তো একটা এপসাইলন নিয়ে নাও। এপসাইলন ডেল্টা ডেফিনেশন কি ছিল কন্টিনিউটির জন্য? যে কোন একটা এপসাইলনের জন্য একটা ডেল্টা তুমি পাবে এফ অফ এক্স ওয়াই মাইনাস এফ অফ এ বিটা কি হবে লেস দেন এপসাইলন হোয়েন এভার এক্স মাইনাস এ একটা নাইবারহুড তুমি পাবে ডেল্টা নাইবারহুড, ওয়াই মাইনাস বি সার্কুলার নাইবারহুড নিতে পারো। আমি সবই তো সার্কুলার নাইবারহুড দিয়ে তোমাদের শিখিয়েছি। এই নাইবারহুডকে যারা নাইবারহুডের মধ্যে সমস্ত পয়েন্টের জন্য আর কি কন্ডিশন স্যাটিসফাই করবে আর কি। ঠিক আছে, এক্স ওয়াই বিলংস টু ডি ডোমেনের অবভিয়াসলি ডোমেন এবং এই নাইবারহুডের যে কমন পয়েন্ট তারা হচ্ছে এই কন্ডিশন স্যাটিসফাই করবে। তো একটা এপসাইলন নিয়ে স্টার্ট করা যাক। এপসাইলন নিয়ে একটা ডেল্টা খুঁজে বার করার চেষ্টা করি। লেট এপসাইলন গ্রেটার দেন 0 বি আরবিট্রারি। বি আরবিট্রারি দিয়ে না ডিরেক্ট আমি এখানে চলে আসি, মনে হয় এটা বেটার হবে যে এফ অফ এক্স ওয়াই মাইনাস এফ অফ 0 0। এফ অফ 0 0 তে 0 আছে, ওটাতে কোনো মাথা ব্যথা নেই, তার মানে দ্যাট ইজ এক্স কিউব মাইনাস ওয়াই কিউব বাই এক্স স্কোয়ার প্লাস ওয়াই স্কোয়ার। ঠিক কিনা? বেশ, তো এখানে সিম্পল ফর্মুলা ইউজ করা যেতে পারে, তাই না? আই মিন এই ফর্মুলাটা, আচ্ছা এটাকে ভেঙে দিই একবার। এটা কি দাঁড়াচ্ছে? এটা হচ্ছে তোমার মড এক্স এইটা আর মড ওয়াই বাই এক্স স্কোয়ার প্লাস ওয়াই স্কোয়ার। ঠিক, এবারে মডের প্রপার্টি যদি ইউজ করি দ্যাট ইজ 2 টাইমস অফ এটা কত হবে এক্স স্কোয়ার প্লাস ওয়াই স্কোয়ার হোল টু দি পাওয়ার 3/2 না? because of that condition, because of this condition, this is x square then divided by x square y square. That means এটা এখান থেকে যেটা দাঁড়ালো this is 2 times of x square plus y square to the power half. ঠিক, এবার এটা less than epsilon if এই 2 times of এই জিনিসটা less than epsilon, that is if এখান থেকে ডেল্টা তৈরি করব আমরা, that is if x square plus y square less than epsilon by 2 করে দাও আর এটাকে এদিকে স্কয়ার করে দাও, that is if x minus neighborhood concept, x minus 0 neighborhood whole square y minus 0 whole square less than delta square, যেখানে ডেল্টা হয় ডেল্টা is equals to epsilon by 2, রাইট? সো ব্যাপারটা তাহলে, আচ্ছা এখানে একটা ব্যাপার বলি যে ডেফিনেশনে দেখবে ডোমেন ইনভলভ করা, কিন্তু এখানে আমাদের ডোমেনটা ইনভলভ করার দরকার নেই বিকজ অফ দেখো ডোমেনটা পুরো R2 তে ডিফাইন করা, ফাংশনটা R2 তে ডিফাইন করা, সেই জন্য ডিটাকে আর নিয়ে আসার দরকার নেই এখানে, এটাই নাইবারহুড দিয়ে একেবারে ডেফিনেশন। সো ফর এ গিভেন এপসাইলন, so for any given epsilon greater than 0 there exists delta, this is depends on epsilon greater than 0 such that mod of f of xy minus f of 0 0 it's less than epsilon for all xy satisfying this circular neighborhood, that is x minus 0 whole square y minus 0 whole square less than delta square. Okay, so because of that f is continuous, f is continuous at 0 0. It is okay. Now we have to study about the differentiability of the function. Okay. So এবার দেখো তাহলে ডিফারেন্সিবিলিটি স্টাডি করতে গেলে আমাকে ফার্স্ট এটা করতে হবে, পার্শিয়াল যে ডেরিভেটিভ গুলো হয় সেই পার্শিয়াল ডেরিভেটিভ গুলো আমাকে একটু আগে ক্যালকুলেট করে নিতে হবে। ঠিক আছে, তাহলে দেখি পার্শিয়াল ডেরিভেটিভ ফর্মুলা দিয়েছিলাম, সেই ফর্মুলাগুলোকে একটু রিকল করে নিই। যে fx at ab if exist, যদি এক্সিস্ট করে তাহলে আমি এই ইকুয়াল টুটা ইউজ করতে পারি, এটাকে ডিনোট করতে পারি। এই যে if limit h tends to 0, that is f of a plus h b minus f of ab divided by b, sorry divided by h, definitely এটা এক্সিস্ট করতে হবে, তবেই তুমি এই ইকুয়াল টু সাইনটা ইউজ করতে পারবে। সিমিলারলি fy at ab, its limit k tends to 0, f of a b plus k minus f of ab ছিল, right, this is divided by k if exists. So by using this formula we shall calculate fx at 0 0 and fy at 0 0. So next another part এ তাহলে চলে আসছে যে নাও ওই যে ভ্যালুগুলো যেগুলো ছিল আর কি, লিমিট fx at 0 0, fx at 0 0, that is limit h tends to 0, f of 0 plus h 0 minus f of 0 0 divided by h if exist, right, understood? এই ওয়ার্ডটা লিখবে সব সময় if exist। এবার এখান থেকে দেখো লিমিট h tends to 0, f of h 0 minus f of 0 0 by h, that is এবার তুমি ভ্যালু বসাও, এটা তো 0 হয়ে যাচ্ছে, আর h 0 means ফাংশনে চলে যাও, এখানে x এর জায়গায় h আর y এর জায়গাতে কত হচ্ছে, y এর জায়গাতে 0, তাই তো, তার মানে h এর কিউব, আচ্ছা বসাচ্ছি আমি। সো দিস ইজ h কিউব minus 0 কিউব by h square plus 0 square minus 0 by h. This is limit h tends to 0. If you calculate the h cube cancel করে, that is 1, because of that condition h tends to 0, it does not mean h equals to 0. It does not mean h equals to 0. So you can cancel out from up and down, and it's independent of limit, so that is the limit is 1. Now comes to next, fy at 0 0, it is limit k tends to 0, f of 0 0 plus k, simple, very simple, just use the formula only, at 0 0 divided by k if exists, so limit k tends to 0, this is f of 0 k, that is 0 cube minus k cube divided by 0 square plus k square, and add 0 0, f gives 0 by k. Now see, this is k tends to 0, this is k cube and minus k cube, by k cube, so that is minus 1. K tends to 0, it does not mean k is equals to 0. So you can cut it. Now this is independent limit, that is minus 1. So you got both the partial derivatives fx at 0 0 and fy at 0 0. Now comes to the formula. Okay, suppose f be differentiable at 0 0. If I consider suppose f be differentiable at 0 0, that means this limit is k tends to 0 0 delta f minus df by rho, this should be 0. But let me check whether this is 0 or not. Now see the formula, this is delta f. Check it, we have to check it. Delta f, what is delta f? Delta f is f of a, that is 0 plus h, 0 plus k minus f of 0 0. So this is f of hk minus f of 0 0, that is f of 0 0 is 0, and that is simple h cube minus k cube by h square plus k square. Now df is h fx at 0 0 and k fy at 0 0. fx 0 0, this is 1, I think 1, yes it is 1. So h minus k and rho is root under h square k square. Now comes to this calculation. So therefore delta f minus df by rho, what is it? Delta f is delta f, where is delta f? Yes, this is h cube minus k cube by h square plus k square minus df means that is h minus k divided by root over of h square plus k square. Needs to simplify. It is h cube minus k cube. It's minus of h cube minus k square h minus h square k minus k cube divided by its power 1 and its power half, so that is h square k square whole to the power 3 by 2. Got it? Now h cube cancel it, h cube it's k cube, so this is just k square h plus h square k divided by h square k square whole to the power 3. Okay, now see, now we have to find the limit hk tends to 0 0, right? hk tends to 0 0. But see, it's very important that this function, see the degree of the numerator, it is h square and h to the k square h to the power 1, that is, see, it's degree 3, it's degree 3, and see it is 3 by 2 and square, it is also 3. So it's a homogeneous function. It's a homogeneous function. And if it is a homogeneous function, limit does not exist. We studied already about that. If it is homogeneous function, then limit does not exist. It is not continuous also. So just passing through the curve, passing through a straight line. Okay, yes. passing through the state line. Approaching the origin. So now approaching the origin. Okay. So now limit hk tends to 0 0. This is delta f minus df divided by rho. That means limit hk tends to 0 0. This is this one. H k square plus k h square divided by h square k square whole to the power 3 by 2. So let us approaching the origin, right, along the straight line. Approaching the origin, the origin along the straight line. This is k is equals to mh, right? Because this is a function of hk, where m is a parameter, where m is a parameter. Now k converted in h, so that means limit h tends to 0. Okay, this is h tends to 0, k, that is m square h square into h plus mh into h square divided by h square m square h square whole to the power 3 by 2. So it is you can cancel out h cube, right? Yes. So limit h tends to 0. It is m square plus m divided by 1 plus m square whole to the power 3 by 2. Since h tends to 0, that means h not is equals to 0. So this is limit independent. So m square plus m divided by 1 plus m square whole to the power 3 by 2. I think there is a mistake. Mistake in calculation. Let me check once. It is h cube. Oh, this is plus. Okay. That means the sign is negative. Okay, just change one sign. Negative. That is negative. This is minus m square. Minus m square. Okay. Now see, this is different for different values of m. If you change the line, we are moving towards origin, right? We are moving towards the origin. But if you change the line, the limiting value will be different. Right? If you change the line, slope will be different. The value will be different. Limiting value are different for every different state line. So which is different for different values of m. Then what does it mean? This means this limit doesn't exist. So limit h tends to 0 0 delta f minus df by rho does not exist. Okay, and the limit does not exist. That means not differentiable, right? Yes. See, the definition of differentiability is if it is differentiable at AB, that means the limit will be 0, but the limit does not exist here. So f is not differentiable, therefore f is not differentiable, therefore f is not differentiable at 0, 0. Now see, come to next question. So that f of xy is defined by xy divided by x square plus y square whenever xy both are non-zero, not together 0, both are not 0 together, and it is 0 when xy both are 0. Is continuous. This is continuous at 0, 0, comma, possesses partial derivatives at 0, 0, but not differentiable. Not differentiable at 0, 0. Already I discussed about this continuity of that function. Okay, so this is already done. Continuity of this function is already discussed. So the left part, I shall discuss now the left part of this question, that is the partial derivatives at 0, 0 and differentiability. Okay. So the solution, f is continuous at AB, that is 0, 0, already done. Now comes to the partial derivative fx at 0, 0. At 0, 0, fx, this is limit h tends to 0. What is the formula? It's 0 plus h k minus f of 0, 0 divided by h if exists. If exists, that is important. If exists. This is limit h tends to 0. I think there is a mistake. It is not k. This is 0. This is 0. Yes. So this is f of h 0. F of h 0 means that is 0. Okay. Y component is 0. Y component is 0. That means this is 0. 0 minus 0 by h. Limit h tends to 0. This is 0. Okay. 0 by h, that is 0. Since h tends to 0, implies h not is equals to 0 and 0. If y at 0, 0, it is also same. No? So similarly, let's try it similarly. Similarly, if y 0, 0 should be 0. right? Same, see once this is a symmetric function, that is if you change x and y the function will be same, so that's why no need to calculate this fy at 0 0. So it's done. Now comes to the our differentiability. Limit okay, if f is differentiable at 0 0, then limit hk tends to 0 0 delta f minus df by rho is equals to 0. Okay, let me check. Delta f, what is delta f? Delta f, this is f of a, that is 0 plus h 0 plus k minus f of 0 0, that is f of hk. F of 0 0 is 0, so f of hk, f of hk means put hk for x equals to h, y equals to k. So this is hk divided by square root of h square k square. Next delta df h fx 0 0 plus k fy 0 0, it is 0. Both the partial derivatives are 0. And rho, this is root under h square k square. So now limit hk tends to 0 0 delta f minus df by rho. Limit, put the values, hk tends to 0 0 delta f, this is 0, this one, so it's coming hk divided by h square k square. Yes, it is coming hk divided by this. Now see, it's a homogeneous function because it is degree 2, in the down part also degree 2. So move along the straight line towards the origin. Okay, approaching the origin, along the straight line, k equals to image, very simple, k is equals to image, where m is a parameter. Right. So limit h tends to 0, that is h mh h square m square h square. Limit h tends to 0, m divided by 1 plus m square, h square cancel out. This is h tends to 0, this implies h not is equals to 0. This is m divided by 1 plus m square, independent limit. So different values are coming for different values of m, which is different for different values of m. So therefore limit hk tends to 0 0 delta f minus df by rho does not exist. Hence, f is not differentiable at 0, 0. Okay. Next, another important question I shall discuss. It is very important question for exam. It is so that fx y, this is square root of mod xy, is not differentiable at 0, 0. First we find the partial derivatives at 0, 0. fx, simple, fx at 0, 0. This is x means h. Okay, h tends to 0. F of 0 plus h, 0 minus f of 0, 0 divided by h, if exists. If exists. Now, see, this is h 0. If you put h 0, that is 0. So limit h tends to 0. It's 0 minus 0 by h. Limit h tends to 0 over 0, that is 0. Similarly, you can find fy also. Similarly, fy at 0, 0, it is also 0. Okay. So now f is differentiable. F is differentiable at 0, 0 if limit hk tends to 0, 0, delta f minus df by rho is equals to 0. Check it. Delta f, this is delta f, it is f of 0 plus h, 0 plus k minus f of 0, 0. F of 0, 0 is 0, and this is square root of mod hk. df, this is fx at 0, 0 plus k fy at 0, 0. 0, and rho square root of h square k square. Check the limit. Limit hk tends to 0, 0, delta f minus df by rho. So limit hk tends to 0, 0, hk tends to 0, 0. Okay, this is square root mod hk divided by root over of h square plus k square. It's homogeneous. Degree 1, it's also degree 1, right? Numerator, denominator, both are the same degrees. So, same approach along the straight line towards the origin, right? We shall go towards the origin along the straight line. K is equals to mh. Okay. For different values of m, we shall go along different straight line and different limiting value you get. So approaching the origin along the straight line k is equals to mh, where m is a parameter. So limit h tends to 0. Okay, I'm putting the value of k, so don't write k in this limit portion. So just h tends to 0, mod of h mh, this is h square k square h square. Now it's very important to keep it in your mind that it is mod, under square root is mod. See, limit h tends to 0, it is just mod h square. Yes, it is mod h square and m divided by root over of same thing h square 1 plus m square. Right? Okay. Now see, it is square, right? So limit h tends to 0, square root of m divided by square root of 1 plus m square. Since h tends to 0, it means h not equals to 0. Cancel out. Okay. So this is limit independent. Square root of m divided by square root of 1 plus m square. This is different for different values of m, which is different for different values of m, right? So limit does not exist. Therefore limit hk tends to 0 0 delta f minus df by rho does not exist. Hence f is not differentiable at 0 0. Next problem, another example. Next question. Let fx y, let us define a function f of xy. This is xy x square minus y square divided by x square plus y square whenever xy are not together 0 and 0 when both are 0, xy is equals to 0 0. Now so that f is differentiable at 0 0, so that f is differentiable at 0 0. Same thing, same approach, everything is same. So solution, first find the partial derivatives. So we have fx at 0 0, that is limit h tends to 0, f of 0 plus h 0 minus just formula, nothing else, very simple, if exists, that is limit h tends to 0 h 0. Okay, so h 0, that is y component is 0, so total is 0. So this is 0 and at 0 0 the value is 0 by h. So limit h tends to 0 over 0, since h tends to 0 implies h not is equal to 0, and that is 0. I think we shall get the same for fy 0 0. Am I right? I think so. Yes, yes. Similarly, so similarly, fy at 0 0 is also 0. Right. Now comes the formula. So if is differentiable, at 0 0, if the limit hk tends to 0 0, delta f minus df by rho is equal to 0. Okay, so we'll check it. Delta f, it is f of 0 plus h 0 plus k minus f of 0 0, that is f of hk. F of hk means hk function square, h square k square, h square minus k square divided by h square plus k square, and df h fx at 0 0 plus k fy at 0 0. These are 0, so df is 0, and rho, it is root under h square plus k square. Okay, so now see one thing, let GHK, okay, I'm taking GHK, that is delta F minus dF by rho. So it is delta F, okay, this is delta F, so HK, H square minus K square, H square plus K square minus this is 0 divided by H square K square square root. It is hk h square minus k square divided by h square plus k square whole to the power, this is 1 and this is half, so it is 3 by 2. Okay, Now find the limit of this hk at hk tends to 0, 0. So let epsilon be arbitrary. Let epsilon greater than 0 be arbitrary. Arbitrary. Let's start with this. F of is k minus f of is k minus it is 0. F of h k minus 0. Yes, f of h k minus 0. So that is mod f of gk. Sorry, g of hk. G of hk. That means this one just mod of hk h square minus k square divided by h square k square whole to the power 3 by 2. Now see, just apply this modulus. It is mod h, break it like this, mod h mod k, next mod of h square, this one, plus mod of k square, because of that this is less or equals to divided by h square k square whole to the power 3 by 2. Right, just use the inequality. It is mod h less or equals to square root of h square plus k square. So this is again less or equals to it is 2 times, so it is just h square k square. For mod h and mod k both it is h square k square, and this one also it is just h square 2 times of h square. Wait, don't use this inequality here. It is just h square plus k square, h square plus k square, right? This divided by h square plus k square whole to the power 3 by 2. Now I think this is square root of h square plus k square. I think so. Yes. So yes, it is less than epsilon whenever this h square k square less than epsilon. That is if don't write anything else. Write in this way. If, that is if it is h square k square. This is yes, epsilon square. That is if in terms of neighborhood of 0, 0, it is 1 second. See, one thing is limit. So use this thing. This is strictly greater than 0. Okay. Use this concept, strictly greater than 0. So this is h minus 0 whole square k minus 0 whole square less than delta square. Here delta, yes, it depends on epsilon. Delta is basically epsilon. Delta equals to epsilon. So yes, what happened? So for given epsilon, greater than 0, there is delta. It depends on epsilon. Definitely it is greater than 0 such that mod of it is z, right? Yes, I took it z. GHK minus 0, this is less than epsilon whenever r 0 less h minus 0 whole square plus k minus 0 whole square less than delta square. Okay, see. So yes, that means limit exists. Limit not only exists, it is 0 exactly. So therefore, limit h k tends to 0 0, delta f minus df by rho is 0, and that means it is differentiable at 0 0. Hence, f is differentiable at 0 0. Next, sufficient condition for differentiability. Sufficient condition sufficient condition for differentiability. Let f from D subset R2 to R be a function and AB be a point in the domain. If fx at AB exists and if yxy is continuous at AB, then f is differentiable at AB. Okay, then f is differentiable at AB. You can write this condition in terms of another form. In another form, if you write it is fyab exists, then it will be fx xy. Anyone. If it is fxab, then it is fy. But if it is fy, then it is fx. So you can write the another form of this sufficient condition for differentiability also, right? But I shall prove it later, because to prove this result we need Lagrange's mean value theorem. Okay, but we did not study yet this Lagrange's mean value theorem. Understood? So let me finish the Lagrange mean value theorem first, then I shall prove it, right? So we shall solve some problems on this result, sufficient condition for differentiability. It is not necessary, that is important. It is only sufficient, not necessary condition. Okay, not necessary, not necessary. Okay, not necessary, only sufficient condition. So next important question, let f of xy, this is x square sine 1 by x plus y square cos 1 by y when x not equals to 0, it is xy product not equals to 0. Okay, x into y not equals to 0. It is just x square sine 1 by x when y is equals to 0. 1 minute, write it in this way. When x not equals to 0, the condition is x not equals to 0. And this is y square cos 1 by y when y not equals to 0. And this is 0 if ordered pair xy is equals to 0, 0. Prove that fx at 0, 0, fy at 0, 0 exists, but none is continuous at 0, 0. Okay, examine differentiability of f at 0, 0. So one by one, at first check it. These are fx and fy exist. Check it first. Fx at 0, 0, that is limit h tends to 0, f of 0 plus h 0 minus f of 0, 0 by h if exists. This is limit h tends to 0. Now f of h 0, right? F of h 0. See one thing, it is very important to select the definition of the function. Look it carefully. It is actually f of h 0, right? That means, see the condition, x y not equals to 0, x not equals to 0, y not equals to 0 and 0, 0. Now see the x component, it is h. So x component is present there, that means this is not equals to 0. So x not equals to 0 definition, use it. Use this definition, x not equals to 0 because of that h. So the definition is this. Now it is h square sine 1 by h minus at 0, 0 it is 0 by h. So this is limit h tends to 0, h sine 1 by h. Since h tends to 0, implies h not is equals to 0. And schema says that this limit is 0. Already we have done. This is 0 in schema. That is in the real line. Right? Next, similarly you can use it. It is okay. Ready. This is fy at 0, 0. This is limit k tends to 0, f of 0 0 plus k minus f of 0 0 by k. So this is limit k tends to 0. This is k component c, that is not equals to 0, y component is not equals to 0. So say the definition y component not equals to 0, that means this is the definition y square cos 1 by y. So this is y square means k square here, k square cos 1 by k minus 0 by k. Okay. Right. Now this implies this is equals to limit k tends to 0 k cos 1 by k. Since k tends to 0 implies k not is equals to 0. Again by SK Mappa this is also 0. So both the limits, both the partial derivatives exist, but they are not continuous. Because of continuity, we need to find the partial derivative at not equals to 0 point. Okay. When first you have to calculate this f of xy. Okay, when xy not equals to 0, find fx partial derivative, and when xy is equals to 0, you got it. You got this value, that is fx at 0 0. We know this, but you have to find fx at fx xy when xy not equals to 0 by just differentiating partially. By differentiating this given function partially, you get this at xy point. So when xy not equals to 0, what is fx xy? Differentiate it with respect to x, that is important, partially, that is del f del x. Y is constant here. This is, so y, if y constant, so it is 0 derivative partially. This is 2x sine 1 by x. So this is 2x sine 1 by x minus x square and 1 by, that is just cos 1 by x. Right. Similarly, fy at xy, that is with respect to y. So function is, this is 0 and derivative of this is cos, right? This is cos. So because of this cos, it is 2y cos 1 by y, it will be plus sine 1 by y. Just differentiate. So therefore fx xy, this is this one when xy not equals to 0, that is 2x sine 1 by x minus cos of 1 by x when xy not equals to 0, and this is 0. We got it when xy both are 0, xy is equals to 0 0. Right. But see, this function, this fx is not continuous because of that portion only, that portion. By SK Mappa using Cauchy's principle, you can apply it, sequential criteria, you can apply it. You know that this limit, this one, this limit doesn't exist. You know it. Okay, so you know that limit x tends to 0, this one, that is cos 1 by x, does not exist. In SK Mappa, I have done this. Okay, so just verify from there. Verify it. Verify. If it does not exist, then it is not continuous. Very simple. Okay. So that means, so therefore, limit xy tends to 0, 0, fx xy, this limit does not exist. Okay, because of that, this limit does not exist. Am I right? See, the total function is total function. If this part does not exist, that means the whole portion limit does not exist. That means it is not continuous. So, fx is not continuous at 0, 0. Okay. Similarly, you can check that similarly, if y is not continuous at 0, 0. Okay, same thing. So next portion is done. Now examine the differentiability of this function. Okay, differentiability comes to check the differentiability. If f is differentiable, if f is differentiable at 0, 0, then this limit what is the limit? Yes, it's k tends to 0, 0, delta f minus df by rho is equals to 0, right? This is the condition. Now delta f, this is f of 0 plus is 0 plus k minus f of 0, 0, that is f of hk. F of hk means which definition is it? This is the first one. This is the first one. Okay. X square sine and y square cos. Okay. So it is h square sine 1 by h plus k square cos 1 by k. And at 0, 0, this is value is 0. So df next, h fx at 0, 0 plus k fy at 0, 0. Yes, this is 0. Both are 0, right? Yes. So this is 0. And rho is square root of h square plus k square. Therefore, it is, let it be GHK. Okay, this is delta F minus DF by rho. Delta DF is 0, so it is yes, this one, right? H square sine 1 by h plus k square cos 1 by k divided by root over of h square plus k square. Okay, yes, it is differentiable. Then check the limit. Check the limit hk tends to 0, 0. This ghk, this one, it is 0. Okay, you have to check it. So epsilon, consider one epsilon greater than 0. It will be arbitrary, right? Now starts from that definition, ghk minus 0. This is mod of h square sine 1 by h plus k square cos 1 by k by root over h square plus k square. Now break this, yes. So this is mod h the square and mod sine of 1 by h plus mod k square, yes, this is mod of cos 1 by k divided by root over of h square k square. Yes, it is again this is less or equals to, this is actually h square and this is k square divided by root over of h square plus k square. Because of that, this is less or equals to 1, sine 1 by h, this is less or equals to 1. Similarly cos also this also less or equals to 1, etc. This is equals to, actually this is square root of h square plus k square. It is less than epsilon if root over of h square plus k square less than epsilon. That is if h square plus k square less than epsilon square. Convert it into delta neighborhood. That is if 0, it is deleted neighborhood. It should be deleted. K minus 0 square less than delta square. Whenever delta, it is just epsilon, depends on epsilon, just epsilon. So for given epsilon, so for given any epsilon greater than 0, then this delta depends on epsilon greater than 0 such that mod of g, yes, it is g hk minus 0, this is less than epsilon. Whenever this is 0 less h minus 0 square plus k minus 0 square less than delta square. So therefore limit hk tends to 0, 0, ghk is equals to 0. That means f is differentiable. F is differentiable at 0, 0, right? This means f is differentiable at 0, 0. Right? So this means that this condition is not necessary. That example shows to you that the condition is not necessary. That condition, yes, that condition. Okay. If it is differentiable, it does not mean these partial derivatives are continuous. Okay. Yes. See, these are not continuous. Yes, yeah. These are not continuous. Still, f is differentiable. Still, these are not continuous. Still, f is differentiable. Okay, see. So this example shows that the condition for differentiability, that the condition for differentiability is not necessary at AB is not necessary. Okay. Next problem, come to next problem. Let fx y is equals to xy into x square minus y square by x square plus y square when this is not is equals to 0, that is order per xy not is equals to 0 0, and 0 whenever xy is equals to 0 0. I worked with this function just a few minutes ago in this lecture. We discussed about the differentiability of this function, and we see that yes, it is a differentiable function. But I want to check it, check the differentiability by the help of sufficient condition of differentiability. Okay. So using sufficient condition of differentiability, just check it differentiable or not. Right? So that f is differentiable at 0 0 by using sufficient condition of differentiability. So any one of these two must be exist partial derivative. Any one of this partial derivative at 0 0 must be exist. Okay, at first you have to check it. Next, this partial derivative is continuous. If I see that this is exist, this is this exists, fx at 0 0 exists, and then find if y xy is continuous or not. Check it. Okay, what is the sufficient condition? Number one is fx 0 0 or fy 0 0 exists, and number two, if you take this one, then fy at xy, or if you take this, that is fx at xy is continuous at AB. This is the sufficient condition for differentiability. So first find these two. So okay, fx at 0 0 again. Fx at 0 0 is the formula limit h tends to 0, f of 0 plus h 0 minus f of 0 0 by h if exists. Now limit h tends to 0, A is 0 because of this y component is 0. See, this is the product xy, so it is just 0. 0 minus 0 by h, limit h tends to 0 over 0, h tends to 0 means h not equals to 0. So this is 0. And similarly, fy at 0, 0, you have to find both this partial derivative at 0, 0. Fy at 0, 0, this is also 0. Similarly. Okay. Okay. Now, consider this partial derivative when function, see the function, yes. When xy not equals to 0, 0, find the partial derivative. This xy not equals to 0, 0. Consider this fx xy. Its partial derivative with respect to x. Partial derivative with respect to x. So y is constant. This y is constant. Leave it. So x into this one, right? Yes, simplify this. X, okay, differentiability to x. So it is actually y into x square minus y square by x square plus y square plus xy into derivative of this portion. So this is u by v rule. This into with respect to x, that is 2x minus x square minus y square into derivative of this, that is 2x by x square plus y square whole square. Okay, simplify it just. So y into x square minus y square, LCM, it is x square plus y square, right? Now plus xy, this is xy, and 2x, that is 2x square y. Yes, it is 2x square y into x square plus y square minus x square plus y square whole divided by x square plus y square whole square, right? Okay, simplify it. This is just x square cancel it, y into x to the power 4 minus y to the power 4 plus 2x is it is 2, that is 4. It is 4 times of x square y cube divided by x square plus y square again whole square. Again you can simplify it little bit. Just see, it is this one and this one. If you take x square, then it is x square y left, and it is plus 4 y cube, I think y cube, if this is y cube, minus y to the power 5 all divided by x square plus y square whole square. Okay. Okay, so this is so therefore fx xy, define this function first. When xy what are the condition? Order pair. Yes, it's order pair. So when xy not is equals to 0 0, the function is this one, x square y plus 4 y cube minus y to the power 5 divided by x square y square whole square. And when xy is equals to 0 0, it is 0. You got it. You got it. If x 0 0 is 0, right? So this is the function. Now you have to check the continuity of this function. Okay. So let consider one epsilon. Let us take let epsilon greater than 0 be arbitrary. So now fx xy minus fx at 0 0, just calculate this. This is 0, so fx xy, that means this one, this is just x square y plus 4y cube minus y to the power 5 all divided by x square y square, this is whole square mod bracket. This is x square, again this is x square mod 1, this is mod, you can use it as mod or okay, leave it. This is mod x square, this is also mod x square mod x square mod y plus 4 mod y whole cube plus mod y whole to the power 5. This is divided by x square plus y square whole square, right? Now use this inequality, mod x or mod y less or equals to this one. Okay, so because of that this is again less or equals to, it is x square y square, this is x square y square and 1, that is x square y square whole cube. No, not whole cube, it is 3 by 2, not 3 by 2. Wait, this is 1, yes, it is 3 by 2. Plus 4 x square plus y square whole to the power 3 by 2 plus close this bracket, this one and this one, plus again this is x square y square whole to the power 5 by 2. Whole square. Now simplify this. Actually this is 4 times and this is 5 times. 5 by 2, that is actually 5, and this is 1, that is 6 times of x square y square whole to the power 5 by 2. Am I right? See, x square plus y square whole square. Just it is just 2, that means it is 2 to 4. So just half. This is 6 times of x square plus y square whole to the power half. See, this is the final stage, and this is less than epsilon if 6 times of x square plus y square whole to the power half is less than epsilon. That is if x square plus y square less than epsilon by 6 whole square. That is if 0 less than deleted neighborhood of 0 0 limit this is x minus 0 y minus 0 whole square less than delta square. Yeah, delta is this epsilon by 6. So corresponding to a given epsilon, you got a delta that satisfies the epsilon definition of limit. So for given epsilon greater than 0, there is delta depends on epsilon greater than 0, such that mod of fx xy, this is fx xy minus fx 0 0, that is continuity of fx. Okay, we are discussing about the continuity of fxy, partial derivative of f with respect to x, continuity of fx. So fx xy minus fx 0 0, this is less than epsilon for all xy satisfying satisfying 0 less x minus 0 whole square y minus 0 whole square less than delta square. Understood? So yes, it is continuous at it is continuous fx xy is, oh wait 1 minute, it is continuity, no? Sorry, yes, it's a mistake. Don't take this deleted neighborhood here, because of continuity, just neighborhood, not deleted neighborhood. Remove this. Okay, so just neighborhood is continuous at 0 0. Hence, by sufficient condition, by sufficient condition of differentiability, f is differentiable at 0 0. Okay.